Good afternoon, Gators. Today I wanted to talk about atomic mass. Now, if you have a chemistry book and you look in the back, there's often a periodic table. There it is. And when you look at the numbers on the periodic table for mass, you'll see that some of them don't have round numbers. For example, chlorine is 35.45, boron is 10.81, and you might wonder, why is that not an exact round number? And there's actually two ways to look at the mass of particles or elements or atoms. One is the mass number, and the mass number is the number of protons plus the number of neutrons in a particle. It's similar to the atomic mass, except it's specific for each specific atom or isotope, which would be all the atoms that are the same of the same element. When we look at the periodic table, we're actually looking at a number called the atomic mass. And the atomic mass is a weighted average of the different isotopes that are found for that element. In order to calculate the atomic mass, you would take the abundance of isotope number 1 times the mass of isotope 1 plus the abundance of isotope 2 times the mass of isotope 2, etc., until we go through all of the isotopes in that sample. Now we could, for example, talk about magnesium. Now magnesium has three main isotopes. There's magnesium-24 that is about 78.70% of standard magnesium. Magnesium-25 is about 10.13%, and magnesium-26 is 11.17%. Now, what we can do then is, instead of talking percents, we can talk abundance. So 0.7870 times 24 AMU plus 0.1013 times 25 AMU plus 0.1117 times 26 AMU would give us 24.32 AMUs, which would be the atomic mass, which is pretty much the number you get in the chemistry book. Now, to just wrap up from the last couple days what we've talked about the subatomic particles that make up atoms, and that includes protons, electrons, and neutrons. Now, protons define what an element is, the identity of the element, and it's the same, in order to calculate it, it's the same as the atomic number for that element. Electrons basically determine whether a particle is an atom or if it's an ion. If it's an ion, it means it's a charged atom, which means it's gained or lost electrons from the base element. If it's neutral, though, it has no charge, which means that the number of electrons equals the number of protons. So in order to determine a number of electrons, you take the number of protons, subtract the charge, and that will give you how many electrons there are. The final particle that's there is the neutrons. And it is possible to have different versions of the same element that have different numbers of neutrons. When that occurs, those different versions are known as isotopes. Now, when you're doing calculations, if the mass number is not given, then just use the number from the periodic table. However, if the mass for an isotope is given, you would use that mass instead of what's given in the periodic table. When you are using the periodic table, the number of neutrons, though, equals the rounded atomic mass minus the number of protons.